Alright, hello and welcome. So today we're looking at rotations. So I've got a few different things here. The horse, which is called the knight in chess, and it's got a starting position. And if we were to think about the knight in chess, it would start at a position here in the center, and we could move it to any of these 8 positions as we learned before in our overview. So what we really want to think about is that the chess piece in this case has already been moved to a starting position, and from there it can be moved to any of the other 7 positions, including going back to its original position, which would be the 8th position. Each move is 45 degrees around the circle. If we connected all the dots, we would get a perfect circle. And so if I were to rotate counterclockwise, each movement counterclockwise would be another 45 degrees. So one movement would be 45, two would be 90, and so on, all the way around. And if I wanted to go clockwise, the same could be stated. So I could go 45 degrees, 90, and so on around. So that's kind of the simple way of thinking about rotations. So let's go ahead and rotate a few different objects and see how it's actually done. Alright, so we're rotating about the origin 180 degrees, and we don't have to state that we're going clockwise or counterclockwise because we are ending here. If we go clockwise, 1, 2, 3, 4, 4 movements is half of the 8 movements that you could do. So 180 is half a circle. So since we're going halfway around a circle, going halfway clockwise is the same as going halfway counterclockwise. So this is the one special case where you don't have to identify whether you're going clockwise or counterclockwise. So I've got my 3 points, A, B, and C. A is at 4, -1, B is at -3, 4, and C is at -2, -2. Okay, so let's start rotating. So let's start with A. A is at 4, -1. 8 movements we can make. So we can go over 4, down 1, or we can go up 1, up 4, and over 1. Left 4 and over, up or down 1, and then down 4 over 1. So there's our 8 movements. You can do this pretty quickly, as you can see. Alright, so let's see here. We need to move 1, 2, 3, 4. 4 movements is 180 degrees. That's half a circle. So we're starting here, and we're going 1, 2, 3, 4, and this will become A prime. And that is -4, 1. So it's left 4, up 1. Okay, and we can get rid of the other 6 dots. Okay, so let's go ahead and do the same with B. B is left 3, up 4, so we can go right 3 as well, and up 4. We can go over 4 and up 3. And over 4 and down 3. And then we can go down 4 and over 3. Down 4 and over 3. Or over 4 and down 3. And then we can also go over 4 and up 3. So there we go. There's all of our 8 points that we could go to. They're all over 4 and up 3, or over 3 and up 4. Or down 4. Okay, so we're either going up or down, left and right, and our 2 choices are 3 and 4. So that's where you get all 8 of these points. If you were to connect them, you'd get a perfect circle. So again, we can go clockwise here, 1, 2, 3, 4. And here is B prime. And that, if we notice, is over 3 and down 4. It's over +3 and then down 4. So that's our new point. We can get rid of these here. And the last is C. C is at -2, -2. So that's left 2, down 2. And so this is a special case, if you recall from the review of transformations that I gave earlier. When you're over and down the same amount, you only get 4 movements. So there's only 4 choices, because over 2, down 2 is the same as down 2, over 2. So likewise, there's only going to be 4 choices. It's always over 2 and up 2, or over 2 and down 2. So this is the special case where you only get 4 choices. And so half of 4 is 2, so we're going to move 2 movements, half of a circle. So 1, 2 movements, and here is C prime at 2, 2. And these points are not needed anymore. Okay? You can connect the dots, A, B, and C. And there you go, you've got your new shape. So our pre-image is A, B, C, and our image, what we got, is A prime, B prime, C prime. So we converted the blue triangle into the red triangle. So I would like us to maybe take a look at the rules. So there are rules, and so let's go ahead and look at rules of rotation. And we're gonna make a list of rules. So we're gonna come up with a few. So here's the first one. If we rotate 180 degrees, remember that can be clockwise or counterclockwise, because that'll get you to the same point. About the origin. So we're going about the origin. We want to be careful, because only about the origin will this rule necessarily apply. It might not apply if you're rotating about some other point in space. So this is a special rule about rotating 180 degrees about the origin. So if we want to, we can first look at point A, which is 4, -1, and it became A prime, which is -4, 1. Notice X and Y, the numbers stayed the same, but the 4 became negative and the -1 became a positive 1. So that's interesting. Let's see if that continues on. Let's look at B. B is -3, 4, and it became B prime, which is 3, -4. So again, the first terms, the x's changed sign and the y's changed sign, but the numbers stayed the same. And then C, -2, -2 became C prime, which was 2, 2. Sorry, I ran out of room there. But you can see that the first term, the x, switched sign. It was a negative and it became a positive. 2 negatives make a positive, so it became a negative. -2. And same with the y. The y was a negative and it became a positive as well. And that happened in all 3 of the cases. So we could write one rule for rotating about 180 degrees. So let's go ahead and get rid of this, because this is how we determined our rule. But our rule is simple, and it is any point P being xy becomes the new point P prime -x, -y. So it changes sign. The x became a negative and the y became a negative, or if it was already negative, it became a positive. So there you go. That's the rule for rotating about the origin of 180 degrees. So if you write this rule down, it will help you in the future. So definitely want to put that in your notes. You might recognize this shape. As a parallelogram. So here we've got a parallelogram, And let's also give them names here. So A, B, C, and D. So we're rotating A, B, C, D clockwise 90 degrees. So let's remember that we can do each point individually. You don't have to try to rotate the whole thing. If you do, you might get the right answer, but you might not too. We're going to start with A. So we're over 5 up 3. So we're going to go over 5 and down 3. And then over 3 and down 5. We could go all the way around, but because we're only going 90 degrees, rotating 90 degrees about the origin, and we're going clockwise, all of our points are going to be into the fourth quadrant. We started in the first, and every single point, since every single point's in the first, and we're rotating clockwise, they'll all be in the fourth quadrant. So we don't even have to worry about these points. We're just worrying about these. So we should worry about these as well. So that's the other issue. So A is over 5 and up 3, or over 3 and up 5. So since we're rotating around clockwise, we don't have to worry about this point for A. So A, 1, 2, 90 degrees is 1/4. So that's 2 movements. That's 2. So we're ending here. And here is A prime. And that is 3, comma, negative 5. 3, comma, negative 5. Okay? Over 3, down 5. All right, B. B is over 4, up 1. So we can go over 1, up 4. And since we're rotating this way, and we wouldn't worry about that point, so we're going to go down 1 and over 4, and then down 4 over 1. So those are our 2 options. So we've got 1, 2 options. So this is our second one in the rotation. So there's B prime, and that is 1, comma, negative 4. Okay. Now we're going to go to C. C is special in that it's only got 4 movements, not 8, because it's the same number for X as for Y. So we have 4 movements that we can do, but again, 90 degrees, 1/4. Well, that's 1 movement of 4. So here it is. So here's C prime, and that's 1, negative 1. Okay? And then D is our last. That's over 2, up 3, or over 3, up 2. So notice that's in the path of the circle. And then we can go over 3, down 2, or down 3, over 2. So remember, we want to move 2 movements. Well, in this case, there's 1 here, and then 2. So this is D prime, not the second one. In here, we're going D has 2 movements. So that's kind of weird, but true. If we were to draw them all, we'd see that that makes sense. So there's D prime, and that's over 3, down 2. And there you go. You connect your dots. A, B, C, D. And you get a parallelogram again, but now it's facing down. So if you look, A, going from D to A we're going that way, and from D to A we're going down now. So we were pointing to the right from D to A, and now we're pointing down. And that is a good rotation. So we did good. All right, so let's see if we can figure out the rule, because we would like to know about the origin. We're gonna just say everything's about the origin. 90 degrees, and we're going clockwise. So A went from 5, 3 to A prime, 3, negative 5. So they swapped positions So if you think about it, p of x comma y became p prime. X and y swap positions, so y comma x, but also this x value became negative, so y comma negative x, y comma negative x. So let's see if that's true. What is y comma negative x of b? Well, that would be 1 comma negative 4. 1 negative 4. And then we've got y comma negative x for c, y comma negative x, 1 comma negative 1, 1 comma negative 1. And then for d, y comma negative x, 3 comma negative 2, 3 comma negative 2. So that's the rule, and that is the correct rule. So you can test it. So x comma y becomes y comma negative x. Pretty neat. So that's clockwise, 90 degrees. All right, so let's keep going. Let's do a couple more. All right, so we've got our 3 points, A, B, and C. A is negative 1 comma negative 4, B is 2, 2, and C is negative 1, 2. So if you're seeing the pattern here, you can pause the video and try it out yourself. We're rotating 270 degrees clockwise. So we're sticking with clockwise for now. And so we start at the green, and we're going to go 270. That's 3/4 of the way around the circle. 3/4 of 8 is 6. So we're going to make 6 movements. 1, 2, 3, 4, 5, 6 movements. And so that's where we're going to end. Okay. All right, so let's go ahead and give this a shot. This really is our last one that we need to do about the origin. All right. So let's start with A. We're over 1, down 4, and then we're going to go over 4, down 1, and then here, and here, and here, and here, and here, and here. We've got our 8 points. Now we can start figuring out where to go. So remember, we're going 6 points around, six dots around. So here's A, 1, 2, 3, 4, 5, 6. And so there's A prime. I didn't make this one quite as easy as the last one in that not every point's in the same quadrant, so I can't say, oh, all our points are in the 3rd quadrant. So now, since we're rotating 270 degrees clockwise, all of our points will be in the 4th. But it doesn't work here, unfortunately. So, but that's okay. This really doesn't take that long to draw all the points and then count. And so this is 4 comma negative 1. 4 comma negative 1. All right. Let's get rid of these. And there's A prime. All right. So let's go ahead and do B. B is 2 comma 2, so that's 2 comma negative 2. Nice. So we're at 2 comma negative 2, and since those are the same numbers, I mean, I know one's positive, one's negative, but they're the same distances, there's only 4 options. There's only the 4 options. So we're starting at B, and we're going 1, 2, 3, 3/4. 3/4 of the way around. 270 is, in this picture, 270 is this big chunk, so it's 3/4 of the way around the circle. So 1, 2, 3, 3 of 4, there's B prime. And that is 2 comma 2. Okay, so we can get rid of the other 2 points that we made, so we don't get confused by them. And last one is C, negative 1, 2. So we've got negative 2, 1. We've got this guy and this guy, that one and that one, that one, and 2 comma negative 1. So those are our 8. It's getting a little busy here, but we can figure it out. So we're at C. 1, 2, 3, 4, 5, 6. So there's C prime. And C prime is negative 2, negative 1. There we go. And we can get rid of the other 6 points that are unnecessary. And there we go. We've got our A prime, B prime, and C prime. We can connect the dots. And the reason it doesn't look proportional is because I actually made 1, 2, 3, 4 over. I made those a lot wider than going down 1, 2, 3, 4. So A is kind of that weird point. It's correct, but my picture is just not very well drawn. So it's not perfectly to scale. So that's why it looks a little funny. But these are congruent shapes, completely the same size and the same shape, just rotated. Okay, so let's go ahead and get our last rule up, and that is, let's do a different color. Do green here, 270 degrees clockwise. So we've got we need to figure out what that is, that rule. So we know A was negative 1, negative 4, and it became A prime of 4, negative 1. So let's see here. They swapped positions, y and x, and the negative 1 became a negative 1. So the x kept its sign, but the y changed sign, became a negative. Negative yx. So let's see if that's true. Let's do negative yx for b. So negative y would be a negative negative 2, which would be 2. X is 2, so 2, 2. Yep, 2, 2. And then c would be negative 2, negative 1. Negative yx, negative 2, negative 1. Negative 2, negative 1. Yes, it is. So this is correct. So this is our rule, and this rule could be memorized. All 3 of these rules could be memorized, and if you memorize them, that could help you out. So you say, wait a second, we didn't do any of the counterclockwise. And you're right. So let's look at counterclockwise. So 270 degrees clockwise is the same as counterclockwise, 2 movements. 2 movements counterclockwise. So what's 2 movements counterclockwise? Well, that's 90 degrees. Let's get our green out. Equals 90 degrees counterclockwise. So both of these, this rule applies for both 270 degrees clockwise and 90 degrees counterclockwise. So let's see here, 90 degrees clockwise would be here, right? That's 90 degrees clockwise. And that's the same as 1, 2, 3, 4, 5, 6. That's 270 degrees counterclockwise. All right? And then the 180 degrees about the origin, clockwise equals counterclockwise. They're the same for 180 degrees. So in the 180 degrees, it's the same. So it doesn't matter. So we've actually built all of our rules here for 180 degrees, 90, and 270, 90 clockwise, 270 counterclockwise, 270 clockwise, and 90 degrees counterclockwise. Definitely want to write these rules down. And that will help you out quite a bit with the assignment, I think. And if you have it memorized, it'll help you with the tests as well. So definitely want to be familiar with the rules. Get those written down. Make sure that you understand them. They will help you out. All right, so here's our last problem. And this one is a little bit different in that we are rotating about a point. And that point is 3, -2. And we're rotating counterclockwise 90 degrees. So notice all of these rules here only apply to rotating about the origin. So you might think, well, we can't use any of our rules, and that makes sense, but we can do something to our picture to make it so that we are rotating about the origin. And that is, we can shift all of our points to a new origin. Okay? So if we said our new origin is 3, -2, let's move right 3 and down 2 and make that our new origin. So that's our new y, and make this our new x. So if we rotate about this new origin, we can actually just follow the rules. So it might be helpful to change the values of our numbers. So 3, -2, we need to change it by moving, since we're moving right 3 and down 2, we need to get rid of 3 units. So we need to subtract 3 from our x's and add 2 to our y's. So a becomes 3 - 3, which is 0, and -2 plus 2, which becomes 0. So our new a is 0, 0. Our new b, and that's because 3, -2 happened to be the point at which we were at, point A, and the rotating about. So it just happened to be that we have a point on the origin of rotation. Okay, so we're going to subtract 3 from 6 to get 3, and then we're going to add 2 to 1 to get 3. And this actually makes sense for our new b to be 3, 3. If you look, we go right from this point. We go right 1, 2, 3, and up 1, 2, 3, 3, 3. And then we need to subtract 3 from -2 to get -5, and add 2 to 2 to get 4, and that will be our new c. From this point, we're going to go left 5, up 4. Left 1, 2, 3, 4, 5, up 1, 2, 3, 4. And there you go, that's our new c. So in the red, we've got 0, 0, 3, 3, and -5, 4. Those are our 3 new points. Okay, so now we can rotate those 3 new points about point 3, -2, which happens to now be 0, 0. We can now use our rule because we're now rotating about the origin. So we're rotating 90 degrees counterclockwise. So we go to our list at 90 degrees counterclockwise. xy becomes -yx. So starting with a, 0, 0 becomes -0, 0. A doesn't change. And that's always true. If you're rotating about a point and you're on that point, your rotation, you move 0. You move 0 units. So A stays where it's at. B, which is 3, 3 now, 3, 3 now, we need to swap them, and it becomes -3, 3, -yx, -3, 3. So B prime is negative 3, 3. So we're going to go, from here, we're going to go left 3, up 3. And there is B prime. And we can actually now see what its end answer is, because our end answer is based on actually moving back left 3 and up 2, right? Left 3 and up 2 will get us back to where we were. So our actual answers, B prime is 0, 1. B prime is 0, 1. It would be, if we wanted to count it, it's left 3, up 3. So it will be negative 3, 3. And then we'd add 3 to negative 3 to get 0. And then 3, we would subtract 2 from 3 to get 1. So we get 0, 1. But we don't have to do that. In our picture, we already know the end answer is 0, 1 for B prime. A prime is actually 3, negative 2. A prime. Because it's our original point. It never moved. Okay? And then C is our last one. And it is at negative 5, 4. That's our new point. And xy becomes negative yx. So, negative y, negative 4, negative 5. Negative 4, negative 5. So we're going to go left 4 from this point. Left 4. And then down 5. 1, 2, 3, 4, 5. Which is actually negative 1. We only went left 1 from our true origin. And then down 1, 2, 3, 4, 5, 6, 7. Negative 7. So negative 1, negative 7. So our C prime is negative 1, negative 7. And this is our new shape here. There we go. A prime, B prime, C prime. And so if you wanted to write your end answer in points, you've got 3 comma negative 2. You've got 0, 1 for B prime. And you've got negative 1, negative 7 for C prime. I don't plan on having you do a lot of these. If I did, it would just be a challenge problem. Because we can move our origin and then use the rule, I just want us to really learn the rules. So we're going to focus our attention on rotating about the origin and not about other points. But I did want you to see that you can do it. And it's doable. This whole thing rotated 90 degrees counterclockwise. So there you go. And we just used the rule. We didn't even use these dots. And really using these dots would be really challenging here, because you'd have to build those dots based off of this being your 0, 0, and it's already kind of a mess. As you can see, it's fairly messy. And because of that, you want to use the rules whenever possible. It actually eliminates the need for this chess idea. But I just think it's so neat, the chess idea. I always throw that in there because I think it's a visual aid that really helps us identify and understand rotations before we actually get into the algebraic rules. And that is about it. So if you have any questions, please feel free to Canvas message me, and I will get back with you as quick as I can. All right, take care.